Let's deal with some basic matrix operations, and we are going to be adding, subtracting, and multiplying by a scalar, and we'll talk about what that means in just a moment. So let's just jump in with this. You operate two small t-shirt booths on the opposite ends of the mall. You have the north booth and the south booth, and your stock is listed below. And we have small shirts, medium shirts, large shirts, extra large, and we have blue, gray, and white. We have that for both the north booth and the south booth. And number one asks us to write two matrices. We're going to call them N and S. N represents the inventory of the north booth. S represents the inventory of the south booth. And let the rows represent the size and the columns represent the color. Okay? This should be pretty straightforward. So capital N is all this information from the north booth, and it's going to be small, medium, large, and extra large. My handwriting was very bad there. And then across the top, the columns are going to be color. So blue, gray, and white. I'll just put a B, a G, and a W. And we're going to fill in those numbers, and it's really as easy as you think. I have 6 small blue shirts at the north side of the mall. I have 7 small gray. I have 5 small white. It's as easy as it looks. I promise this lesson is not hard at all. Doing this lesson so we can build to much more complicated things. And I'm talking while I'm writing. Apparently not anymore. Wasn't that coordinated. There we go. So we write this. It's really straightforward. I'm getting the information from up here, as you are well aware. Okay, so we've answered number one. Now let's answer number two. What is N32? Okay, that's the third row, second column. What is S32? That is third row, second column. But keep in mind that this one is N and this one is S. So let's just go ahead and answer those. And in third row, second column, so third row, small, medium, large. All right, third row. Second column would be not blue, but gray. And so a large gray t-shirt. So N32 is 3. We have 3 large gray t-shirts at the north end of the mall. Okay, now we're going to deal with this one. South end of the mall, 3-2. Third row, second column. We're in the same location, different number, but we're in the same location, and that's going to become important. That's one of the big ideas of this really short lesson, is that we're going to be adding corresponding parts. So this is going to be 2. N32 is 3. S32 is 2. If I were to add these numbers together, what would it represent? Well, if I was to add them together, I would get 5. 3 plus 2. I'll go ahead and write that. But I would have 5 large gray t-shirts in the mall total. I have 3 on the north side, 2 on the south side, but that would be my total. And again, the big idea behind this one individual problem that is so ridiculously easy is this. Whenever I add matrices, I'm going to add the corresponding parts. Otherwise, things don't make sense. Let me finish writing and then I'll say that again. So we have 5 large gray t-shirts in the mall. Like in the mall, not just north, not just south. It's the total. So whenever we add matrices, we add the corresponding parts because it wouldn't make sense otherwise. So let me grab another pen and I'll point and you'll see what I mean. If I was going to add 6 plus 3, it makes sense because I have small blue t-shirts plus small blue t-shirts. I'm not going to add this 6 plus that 5 because I'm adding 6 small blue plus 5 medium gray, and that the context of that doesn't make sense. Now, if I want to know the total number of t-shirts, that's different. But if I'm categorizing these based on size, based on color, I need to add individually. So that's actually what's about to happen for number 3. We're going to calculate N plus S. Notice the capital letters. We're adding the actual matrices together. We're going to call it T for total. And T equals, and if you want to write small, medium, large, and extra large, you can. I am. Because that is what it represents. And then blue, and then gray, and then white. And when I do this, it is honestly as easy as you think. So here goes. Small blue t-shirts would be 6 plus 3. And then small gray t-shirts is 7 plus 2. And then small white t-shirts is 5 plus 4. And I'm just going to put those numbers. 6 plus 3, 9. 7 plus 2, 9. 5 plus 4, 9. That is a coincidence. That does not always happen. All right, medium blue is 10 total. Notice where I'm pointing. Medium gray is 13. No, yeah, it is. My goodness, I'm struggling right now. That is 13. 14. Oh my goodness. I'd start the video over, but I don't want to. The math was so easy that I forgot how to add 9 plus 5. And then I have 6 plus 8, and I'm feeling pressure right now. That's also 14. So here we go. 10. Let me get my calculator here. 9 plus the 5 is 14, and then another 14. And then we're just going to add these, and it is simple unless you're struggling with basic addition. So 8 plus 8, and then 5, and then 8. Yeah. 8, 5, 8. You can speed through this part. You're undoubtedly going to go faster than me on this. 6, 12, and 10. 6, 12, and 10. And then just to be clear on number 4, what is T for 3? Notice this is a T, a little t, means I don't need the whole matrix. I need a specific number. Again, the vocabulary for that is it's called an element. So a specific element in this, and I need the 4th row, 3rd column. 4th row, 3rd column, that would be a 10. So it is 10, and it is extra large white t-shirts. Extra large white t-shirts. Okay, here we go. Number 5. Suppose you operate t-shirt booths in 4 different malls. Okay, what could 4T represent? Let's suppose that if T is the total amount of inventory I have in this one specific mall, but I operate t-shirt booths in 4 different malls, what could 4T represent? It would represent, and I didn't leave myself much room to write, so I'm going to do a little bit of work over here. I'm going to write down what it means here, though. This could represent the total inventory of all 4 mall locations. Assuming that this represents the inventory in every location, if I multiply by 4, then I would have the total inventory. So this is scalar multiplication. This is what I'm doing, where I'm basically just going to multiply everything by a specific number. And I'm going to do that work up here. So the actual work for 4T, which it did not ask me to do, would be basically 4 times everything up here. And so this would be 4T, and that is 4 times 9. 4 times 9, 4 times 9, 4 times 10, 4 times 14. Hold on, let me struggle with that one. No, I'm kidding. 40 and then 16, 56. Yeah, and 56 again. And then 4 times 8, and 4 times 5, 4 times 8, 4 times 6, 4 times 12, 4 times 10. It's as easy as you think. Okay. 3 more problems down here, and these 3 problems are just going to drive the point home of what to do in specific situations based on the way things are represented. It'll go very quickly. First, we're going to state the dimensions of each matrix. I'm going to switch colors for that. Let's go blue. This matrix has 2 rows and 2 columns, so it's a 2 by 2. This one has 3 rows and 1 column, so it's a 3 by 1. Another 2 by 2, another 2 by 2, another 3 by 1, and I want to point out something here. I'm going to slow down my pace a little bit. Probably should have done that earlier. But I'm going to slow down the pace a little bit and slide up for just a second. Notice that when I added n plus s, I had 4 rows and 3 columns, plus 4 rows and 3 columns. And I got 4 rows and 3 columns. I didn't stretch it out anymore. It didn't shrink. But I had to have the same dimensions to add or subtract. That's going to come in handy in the next lesson. So same dimensions to add or subtract. Otherwise, your dimensions are mismatched and your data is mismatched. Like if I had an extra column over here and I wanted to add them together, I'd be like, well, I have nothing here. And you could say, well, there's a 0. Then I'd need an extra column of zeros. I would need some other data to fill in those gaps. I need these to be the same dimensions. So if I was to say, hey, what's A plus B? Well, good luck with that. So we'll be like, add those and then add that to, but no, and then add, but what about the 6 and who's gonna, no, you can't do it, just no. So that was number 6 when we stated the dimensions. Now we're gonna find A plus C minus D. Don't make it harder than it is. We have a 2 plus 2, 2 by 2, sorry, plus another 2 by 2, minus a 2 by 2. Whenever I'm done with this thing, I better have a 2 by 2. Like, I'm gonna get 2 rows, 2 columns, and I'm not even gonna show my work. So it's gonna be A plus C minus D. So 2 plus negative 5, so negative 3, minus negative 9, so plus 9, so negative 3 plus 9, 6. So this number right here, and I will show the work on the first one, was 2 plus negative 5, we'll do it like that, minus negative 9. That's where that came from. This number is going to be the negative 3 plus 3 minus 8. Negative 3 plus 3, so 0, and then minus 8 is going to give me negative 8. Don't make it harder than it is. Just pick the correct location and do the math on those. So A plus C minus D. So 4 plus 10, 14. 14 minus 9. I think I should know that one. I believe that's 5. I counted that earlier. 1 plus 4 minus negative 1. There we go. Okay, I'm going to show a little bit more work on number 8. I was looking at the 4 there. And as I do, you'll see where this is going. So here's E. And then minus 4B. And then, if I wanted to stretch this out one more step, I could go negative 12, 15, 3. And I'm going to call it plus. And I want to change this, and you don't have to do it. This is kind of middle schoolish, but we will. So negative 4 times that is going to give me 12. Negative 4 times that is going to give me negative 16. Negative 4 times that is going to give me negative 24. So negative 12 plus 12, 0. 15 plus negative 16, negative 1. 3 plus negative 24, negative 21. And there we go.